Hello everyone. Today I am going to discuss the third problem of AtCoder Beginner Contest 288. So there is a long gap between the last video and this video. So sorry for that. I'm not participating in the recent code forces or AtCoder or LeetCode contest. So I am not making any videos. So this contest to me is a bit on harder side. It could be that I am out of practice, or it could be like the questions are hard, you can say that. But for me it is kind of a deep to code forces deep to problems. Like this C is definitely at coder beginner contest D on the other contests. So let's jump into the problem. So what is the problem? The problem is don't be cycle. So we are given a simple undirected graph with n vertices and m edges. The vertices are numbered from 1 to n, and the ith edge connects vertex ai and vertex bi. Okay, so there is the simple graph given like n vertices and m edges, and ai and bi are connected by a undirected edge. So what is a simple directed graph? So simple undirected graph means that the graph does not have self loops or multiple edges, but the graph could be disconnected, and there is a catch in the sentence here. The graph can be disconnected. So so let's say this is also a simple graph, simple undirected graph. So this is also a simple undirected graph. Okay, so let's say this for this graph, what we have to find is that the minimum number of edges we have to remove such that there is no cycle. So for that you can remove this edge and this edge. So total number of edge removals are 3. So this is quite a basic observation problem, but the implementation is a bit on like we have to know like DSU or some DFS. But the observation is quite straightforward. The observation is that for any undirected graph, so this undirected unconnected disconnected graph could have multiple components. Like that, this graph has this first component and the second component. Now we have to find the number of edges in these two components. Let's say E1 is the number of edges in the first component, and E2 is the number of edges in the second component. And for every component they are disconnected. Now we have to make them a tree. So in a tree with let's say size S, what is the number of edges in a tree? The number of edges in a tree will be S1 minus 1, or you can say V1 minus 1. So let's say it is V1 minus 1, and for this it is V2 minus 1. So E1 is the number of edges in this component, and V1 is the number of vertices in the component. So we have to delete this. E1 minus V1 minus 1 number of edges will be deleted from this component, and E2 minus V2 minus 1 edges will be deleted from this component. So the problem is quite straightforward. We have to build the components and then find the number of edges and the number of vertices, and then add this value to the answer. So answer equals to this value plus this value. Okay, I hope you got it. Now let's jump into the implementation. So the implementation, I have used DSU here. So you all know about DSU, the disjoint set union. So for me, this type of problem is solved by the DSU. I generally approach this problem with DSU because in DSU we have some unconnected trees. So this first component will be one unconnected set. Sorry, first one set. The first component will be one set, and the second component will be the other set. And for each set, for each disjoint set, we have to find the number of edges and the number of vertices. So here you can see in the definition, I have the size array. Every size of every tree, if size of every tree node will be 1, and the number of edges is 0. So you can say here, see here, is that the size of each node is 1 and the number of edges is 0. Now let's find out the how the union is happening. For union, so if the xs equals to ys, what does it mean? I hope you all know about DFS. So let's say this is our first component, and this is our second component. We will find the parent node of each component. Say 1 is the parent node of first component, 3 is the parent node of second component. Now we are adding edge between 1 and 3. So what is the total number of edges in this set? So let's say S1 and S2. So what the total number of edges in this disjoint set will be now the number of edges in this set and the number of edges in this set and plus 1. Okay, so here what I am doing here is that the number of edges equals xs equals to the number of edges in xs plus the number of edges in ys plus 1. Okay, And for size, the size will be nothing but the number of nodes in the this subset and the number of nodes in this subset. So xs plus ys. Okay, size of xs equal to self of size of xs plus size of ys. Now there is a catch. Let's say 1 2 and there is 3. Now we want to add age between 1 and 3. So if we add age between 1 and 3, the parent node of this 1 will be also 1 and the parent node of 3 will be also 1. If you know about the disjoint set concepts, then x is equals to ys. Then we will not increment the value of size, the array of size, but we will just increment the value of age by 1. So what I am doing here, if x is equals to ys, that means that this is a cycle. We are just incrementing the value of age by 1. Okay, I hope you got it. And here what I am doing, here I am just unioning the x and y, the ages. This is straightforward DSU stuff. So now this is finding the parent node of the I plus 1. Now we are just checking, like let's say these are the two graphs, 4 5 and 6. So we'll just iterate over this I equals to 1, then mark 1 as 2, and next time when we come to I equals to 2, the parent of 2 is 1. So this is already marked, so we'll like jump to 3. Now the parent of 3 is also 1, so we'll just jump to 4. Okay, that is the concept here. So we are just marking the visited of p equals to 1, and this concept I have already mentioned, that age of p minus size of p minus 1. Here we have to just mark some this value for each and every subset. I hope you got my explanation. I will provide the link of this code in the description box. There could be some mistakes in the video because I am not making videos for a long time. So please write the constructive criticism, and please like the video if you find it helpful, and subscribe to the channel. Thank you.